So thank you very much for giving me the opportunity to introduce once again. Last year it was also I had the honor to do it once again. openMDM. It's a project which is more on the basic. It's an infrastructure project and about data management, and a lot of the projects which are discussed here might benefit from it, because data management is something which is already, or in many cases, behind. But let's briefly start about me. I'm Hans-Dirk Walter. I'm working for a company called Karakun. I'm quite sure that not everybody in the room has ever heard about it. Just who has ever heard about Karakun? Okay, I'm working hard that the next time it will be more here, but I'm quite happy that at least a few showed up. So Karakun is a software company which has various business areas. One is the digital engineering solutions area that is relevant here for this context, but we do also custom solutions and natural language processing and artificial intelligence-based text analysis, which is a specific topic. If you are interested in it, just join me after the session. And we are also proud to be engaged in open source as a team since about or more than 20 years. We have did a lot of projects, and you see them here in the below in the light gray. And currently our main things is Java Web Start. Open Web Start is a replacement of Java Web Start. For everybody who has Java clients still in production, it might be a good thing. And in the automotive area, openMDM and software-defined vehicle. So openMDM. openMDM is a working group. Like many working groups in the Eclipse ecosystem, I think we have one special thing. We are active since 2014. We're quite in, yeah, you see my gray hair. So it is quite an old working group. And also we call our group openMDM. We have only one project in focus, unlike other working groups. That is the project which you find under MDMBL, if you browse through the projects. But because we normally don't speak about MDMBL, if we speak about the software, we use the same name, openMDM. And what is it about? It's about a standardized management of measurement, test, and simulation result data. So all what you create during simulation, during testing, during measurement can be managed using openMDM. And here below you see the current members, ranging from BMW to the ASAM organization as a guest member, because we are very dependent and cooperating with ASAM. I think there was just the OpenX standards were mentioned in the former talk, and we are mainly using ASAM ODS as a standard. And here you see the URL of the web page. And also I'm quite sure that most of you don't need this information on this slide, that why do you need data management. Surprisingly, in many discussions, or in some discussions during the events I'm joining, people tell me, yeah, why I store my result data on files or use a database, why do I have to care about more things? And though I take this minute to repeat, that is, if you generate all these tons of data and you want to, in the end, to have some trust in them, and you want to have some certification, validation, whatever, it is very helpful that you can trace down where the data came from, how they are interrelated, and for this you need besides the raw measurement data, also a bunch of metadata to describe all these things. So, openMDM, as I mentioned in the last slide, is a group which exists since 9 years, and there exists some software and real applications which are already in production and used by organizations for doing their business. It's not just prototyping, it's not just demonstration, it's real there. For instance, some examples in the NVH area, there are productive crash test applications. They are used in the quality assurance for e-engines. They are used as foundation for parameter databases, technology databases, or we call it functional data. And this is the screen shown left. I can show this screen because it's our own product. And in the end, also for big data analytics for all these result data. And what is special in openMDM? It is there are two aspects. The first aspect is the modeling capabilities. The core is based on a fixed standard with predefined, clearly defined sound semantics, but there is beyond that to allow you to implement your own applications, to automate your own processes, is an extension mechanism that allows you to create your own specific models for your components, for your systems. And the second point is, I stressed the importance of metadata just a few minutes before, is that these metadata are tightly integrated with the real raw data, real measurement data. And the first thing is, the magic behind the first thing is that openMDM offers an extensible data model, a predefined thing. And the second one, I hope the time will be sufficient. I will try to give an illusion by a demo. It's not a real demo because of the technical hiccup I would have. It's a movie. But if you want to see it live, you can join me after the session. And I'm very happy to show you the system in a live demo. So the integration of the mass data and the metadata, I will try to transport via this movie. So a very brief overview of the technology itself. The core of the project is the business layer, is an API, a REST-based API, which allows you to store and retrieve your data. As I said, this is based on the ASM ODS standard, and it offers adapters. Currently, it's the ODS 5 adapter for the insiders who know what ODS 5 is. Oh, by the way, who is aware of the ASM ODS standard in this room here? A little bit. Okay. And the ODS 6 stepper is going to be implemented soon, I guess. And in order to play around with data, in order to have some first application, the project also offers a UI, kind of explorer, like the Windows Explorer or Mac Finder, to use the system from the first place. But the normal thing is that you create your own applications on top of it. Yeah, and the data currently are imported by or integrated by means of files, by files that the test system or simulation systems are generating, but there is no principal reason why not only also network-based over-the-air integration should be possible. But of course, currently all applications work by means of files. And so be patient. Now I will go through all these entities one by one, and I hope you will stay here. Now, this is just to give you an impression how many entities and how rich this data model currently already is. And there are also the hook entities for your extensions. So I think there's a lot of semantics in this model which you can use out of the shelf for your applications. So now it comes the hard thing. I have to switch to a different, to a movie by using a different computer. I hope it works. No. What I have to do else? Yeah. Thanks, Annie. So, as usual, if you start an application, you have a login. This shall visualize that the underlying system has a very, very rich and sophisticated access and access control system. So you have very fine granular access rights to define who shall access your data. And then you get the possibility to search your data as it is usual. And if what you see now here on the left side, that is the structure which is mainly created by those bunch of entities you have seen before. It starts with the test, then come test steps, and below you see the single measurements. So for instance, this one which was now marked below, you see some channel groups which really contain the channel data, the raw data you created. By the way, the data we use here are contributed by Audi a few years ago with a self-driving car experiment. So a public data which everybody could access. So if you see here as first some general metadata, and now you have really some description of what you have tested, your unit under test. In this case, it's an e-tron of Audi. Okay, the data was provided by Audi, and you have a lot of attributes which are already defined in this model itself, but you can extend them by your own additional attributes if you want, like. Then you have also a huge set of information about the test equipment, which sensors you have used, which lidars you have used, whatever you have in your test setup. It's up to you. And again, some attributes are predefined, and some you can add at a later stage for your own applications. Now we go to the next part. We can access now the real channel data, and as you can see, you have here some units. This is meter per second, square second, the acceleration, which is a kind of a natural thing. And if you want to have a glimpse in your real data, you can have this as well. In this UI, you have the chance to use XY chart wire. First, you select a channel group, which is one which you see here, the acceleration XY. Then you have the chance to select also one or more of the concrete channels within the channel groups. And the X channel in this case, as in many cases, is just the time. Because a lot of channel data are time series data. And now you have to wait a little bit, because we normally access now the real mass data. And you can see this interesting diagram, which actually I'm not able to interpret. But it has something to with acceleration, and this second part with the brake pressure, the contrast, if you want to slow down. And this is quite realistic. Normally, you have to wait a little bit, but for this you can also use, of course, big data clusters to be more efficient. So As we have seen, we have access to both the metadata and the raw data, and it is tightly integrated, and this is one of the big strengths of openMDM. So, okay. So far, so good. Now go back to the, oops. Okay. So we would be, as a working group, we would be happy, of course, to get new users, new interest parties who are willing to try it out, to give a try, and maybe to contribute if things are missing. There are, for instance, in some discussions I have some people asked whether we also would be able to support other data formats than the ODS data format. Then there is no technical obstacle which principally would speak against, but of course it would cause some work to make this happen. But this would be an idea for this community and especially for the other working groups, which might be also interesting stuff to add. But even if you don't want to change it, why can you use it or should you use it? It's open source. We are an open source conference here. Of course, it's open source. And it's based on a standard. You are interoperable. You have no vendor login. And your engineers, you yourself can create your own models, your own component and system models. You are not dependent on what have people defined elsewhere. But you have a very variable core set of things which are predefined and have a very sound semantics. If you store your data, if you manage your data via openMDM-based system, although your tests are traceable, you can show what have you derived over the time and how the models have changed, and you don't need to care about the version management for all these things, or to beware the consistency between data and the models you have evolved over the time. And it exists. Just check it out. Okay. And if someone wants a test installation, just join me. I'm here for at least until Wednesday evening, and we can discuss this as well. Thank you very much for your patience.
Thank you, Hans-Dirk. Are there any questions?
Maybe a simple one. How do you get data into your system? So do you have some import or fast data?
Yes.
Maybe I missed something, but
yeah, no problem. That is normally the data imported by means of files. So in one scenario, for instance, there are the test equipment in the car with hard disks. The hard disks are inserted into an uploading station, and from this they are imported into the system. And of course, if the data format of the test system or simulation system is quite different, or is different from that what the system here is supporting, openMDM supporting, you need the pain to convert the data.
Further questions?
Doesn't look like.
Yeah, then thank you, Hans-Dirk.
You're welcome.